Good afternoon, professors. Welcome for the third session of today's FATP. And we have our resource person, Dr. Sonia Jenifer Rayen, ma'am. She's currently working as associate professor in JPR Institute of Technology, Chennai. She has published more than she has published more than 50 papers in journal and international conferences, and she has published two books and have applied for two patents. And she's acting as a reviewer for three journals. And her areas of expertise are computer architecture, data structures, computer networks, artificial intelligence, human-computer interaction, and data warehousing and mining. I welcome you, ma'am.
Thanks a lot, ma'am. Thank you. Thank you for the brief introduction.
Welcome, ma'am. You can start your session, ma'am.
Yes, ma'am, I started.
Okay.
Ma'am, is my screen visible now, ma'am?
Yeah, ma'am. It is visible, ma'am.
Okay, yes. Good afternoon, all. So, any idea about what is sorting? What is sorting? Yes. Dear professors, can you all please talk? What is sorting?
Ma'am, they have posted in chat, ma'am.
Oh, okay. Yes, okay, thank you. Thanks a lot. And again, as
Ma'am,
you all said,
your
ma'am,
voice is not
yes.
audible, ma'am.
Ma'am, am I audible now? Ma'am, can you hear me? Ma'am, can you hear me?
Ma'am, yes, ma'am. It is audible now.
Okay. Dear all, kindly excuse me. I actually had an issue while connecting through my system because it says the call size is large, so I was not able to connect. So kindly excuse me for using the phone. So yes, thank you for your responses. So I can see all your responses again. What is sorting? Today's life, all of us, even we as professors, when we generally have to sort some data. Again, for example, we have to review some data. In that case, we go for sorting. A real-time example of a sorting would be maybe when I want to sort the names in an alphabetical order, or I want to see the person who has got the highest result. I want to sort the marks from the highest to the lowest order. In that case, I can go for sorting. So these are the real-time examples of sorting. Okay. So let's see the various other examples of sorting. So yes, so generally, as I said, when we have a list that contains exam scores and that we want to sort it from the lowest mark to the highest, where we want to see the student who performs very badly in class, or when we want to see the topper in the class, in that case, this will be really useful for us. And next, again, when we want to list point pairs in a geometric shape, and then again, when we want to sort the students in the alphabetical order. Another question is sorting related only to numbers. Do we basically sort only numbers, or we sort anything else? Yes. Do we sort only numbers, or sorting is for both alphabets as well as for numbers? Okay, sorting can be used for both alphabets and numbers. When I'm using my alphabets, I call it as my lexicographical sorting. That is A to Z. When I generally want to arrange the student's name in the attendance order. And what other sorting can I use when I want to use for numbers? I can either have my ascending order or my descending order. Yes. So generally, why do I really have to sort? So first we saw what are we going to sort, and now comes the question, why do we generally need to sort something? Again, when I want to retrieve something faster, I have to sort it. Only when my data is arranged, it's easy for me to retrieve that data and to perform any particular task in it. Again, it is also okay, yes, again the appearance. It always looks nice when something is arranged, or when something is very neatly kept. So, and even the databases for that instance, I generally prefer it like that. When I have to store the data of 52 students, I generally prefer like when the names are in the alphabetical order rather than the first name starting with a Z. I prefer the first name starting with an A. So again, as I said, sorting you generally go for two reasons. First, my searching becomes efficient. Second thing, it looks nice. Yes. And again, this point is similar to my first point. Whenever I'm going to search something, it is again going to be very easy when I'm going to take something from a sorted list than from an unsorted list. And then we have just a quick history of sorting. Okay, so sorting is something initially all our data we were using, even our secondary storage devices, where we had large amount of data. In those cases, it was always better when our data is going to be in a sorted manner. Okay, coming back, today my topic is like going to be two topics they've given me. One is radix sort and the other one is shell sort. Okay, so radix sort is again one of the basic kind of sorting, and it started in the year 1890. And again, the radix sort is nothing but it has the base of a number system. Okay, we for us our base is going to be 10, the decimal value. Okay, we'll come back to all this later. There's number of buckets, sorting, and all this. We'll come back later. Radix sort sometimes may be called as a bucket sort also. Okay, and let's see an example. So this is going to be my input data. So my input data, I am going to have totally eight values. So I have to sort this data according to my radix sort or my bucket sort. So first thing, this is going to be my initial bucket. So what is this bucket going to have? It is nothing but it generally resembles the digits from 0 to 9. So here my maximum value, or what is the maximum digit that I'm having? I'm having a one digit number, a two digit number, and a three digit number. So my maximum value is going to be my three digit number. When I'm having a three digit number, it means I'll go for three passes. If I'm having a four digit number, it means I will go up to four passes. So the number of digits depends, the number of digits and the number of buckets are directly related to each other. So in this case, my highest digit is going to be only a three digit value. So I will go for three passes. So let's see the result after pass one. So in my pass, okay, yes. So now what happens? I have to start filling my values. So yes, so first is going to be 478. So where will I place 478? The last position of, the last digit of 478 is going to be 8. So I place it in the digit called 8. The next one, or the bucket called as 8. The next value I have to, what is the next value that I have to press in? I have to place my 537. So 537 gets placed where? It'll get placed in my position number 7. And next I'm going, excuse me, next I will have my 537. So 537, where will it get placed? The last digit is going to be 7. So it gets placed in the bucket called 7. 9, again, it doesn't have any. So it's just a single digit and we take the last digit 9. So it gets placed in the bucket called 9. Where does 721 get placed? 721 again gets placed in the bucket called 1. And then 3 gets placed in the bucket called 3. And then where does my 38 gets placed? My 38 gets placed in my bucket called 8. And then my 123 gets placed in my bucket called as 67. Any doubt till here? Or can we proceed? Can we proceed? Yes, can we proceed? Okay, so after pass 1, now how do I give my values? So I just take my values according to my bucket and I write the values. What is my first value? 721. The second bucket has no value, so I don't write anything. What is my third bucket's value? I have 3, 123. So my 4, 5, 6, I don't have any values. And then I go to my 7. So what are my values there? 537 and 67. Again, so I write it down. And then my 8, 478 and 38. And then comes my 9. So this is going to be my output after pass 1. So now I go back to my pass 2. So again in my pass 2, what will I consider? So I have to consider, in case of pass 1, I considered my last digit. In case of pass 2, I will consider my second last digit. So second last digit is, so 721, where will I place it? I will place it in my value called 2. In a bucket called as 2, I will place my 721. And for 3, where will I place my 3? So 3 is nothing but 0, 3. So I place it in the bucket called as my 0. And then where do I place my 1? 123. 123 gets placed in the bucket called as 2 because I'm considering the second digit. And where does my 537 gets this stored? It gets pasted in my 3 bucket called 3 because last second digit. And then my 67. And what happens in case of my 67 is that, what is my last second digit? I have my 6 and 7. So it gets placed in my 6. And then 478, where does 478 gets pasted or stored? In my bucket called as 7. And then my 38 gets placed in my 3. And 9 gets placed in 09. So any doubt, can I proceed? Can I proceed?
Ma'am, it's clear, ma'am.
Okay, thank you, ma'am. Thank you. So yes, so this is what happens. So in case of a sort pass 1, I consider my last digit. And here now what do I do is I consider my second last digit is what I consider. So after my pass 2, my values will be, so all the values from the bucket is going to be printed. And then comes my pass 3. So again in pass, before I start my pass 3, I must take the values of my pass 2. So again for the pass 1, the value is going to be my input array. For my pass 2, the input is going to be the second pass's value. Similarly for the second one as well. So now for pass 3, the input is going to be the value of pass 2. So here, what will I place it again? For the third pass, what should I consider? Again from the last, the third digit. So when I do it in that case, so what do I have? For 3, it is going to be, whenever I don't have values, another thing what you can do is, you can write it as 0, 0, 3 also. Because my highest digit is going to be 3. Okay, so I can add 2 zeros. It doesn't change the value of my number. So for 3 it is going to be 0, 0, 3, and for 9 it has to be 0, 0, 9. And then for 721, where will I place it? So I place my 721 in my bucket called 7. And my 123, I place it in my bucket called I place my 123 in which bucket? The first bucket. 537, I place it in which bucket? I place it in the 5. 38, where do I place it? Again in the respective bucket. So 38 get placed where? It is 038. So I place it in the first one. Similarly for 67 also, I consider it as 067. So I place it in the bucket called 0. And then 478 also gets placed there. Where does 478 gets placed? 478 gets placed in the bucket called as my 4. Because I'm considering my from last, the third digit I am considering. So I consider from my last, the third digit. So if it's just going to be 3, I use it as 0, 0 and my 3. Okay, coming back. So now how will I take my values? In my bucket 0, what are the values that I will have? I will have my 3, I will have my 9, I will have my 38 and 67. In this case, it is fine. Else, suppose if the values are not in a sorted order, I can take it and sort it. That is, for example, if I'm going to have 9, 3, 67, 38, I can take it and then write it as the final sorted list is. So this is all is going to be about radix sort. So again, a quick overview. In case of my radix sort, yeah, we actually take the base of a number system and we basically use the base value as 10. The decimal value 10 we are considering. And here it is nothing but a bucket sort where we are going to have buckets from 0 to 9 and we are going to place the values in the appropriate positions or in the appropriate buckets. The number of passes generally depends on the number of digits. For example, in my case, in this example, we had 3 digits with the highest value. So we took up to 3 passes. If we are going to have up to 4 values, sorry, 4 digits, not 4 values. So I will go up to 4 passes. So the number of buckets is very important. And then we started from the least significant bit. That is from the last value we take till the most significant bit. And then this keeps the starting more stable. Again, we go with one digit. First, least significant digit. The next one, least significant plus 1. And then we go for till we finish the passes. So this is all is going to be about my radix sort. Coming back to shell sort. So what happens in case of my shell sort? Shell sort is nothing but again we use, okay. So I hope insertion sort is being completed. Here in case of our insertion sort and other sorts that we use, we had something called as sorted array and unsorted array. So we keep arranging the values one side. And so that forms the sorted an array and the other one forms the unsorted array. So however, in shell sort, what happens is what people thought was, for example, if I want to sort 9 values, so again I have to go for so many passes. So what they thought was we can take 5 values separately and then we will sort that first and then go back. So maybe I will show this with another. I had another example also. I'll just show that to you. That may be better. So yes. So here my n value is, what is my n value here? I'm going to have 9 values. Okay. So 9 is the number of values that I'm going to have in case in anything. N is equal to 9. And I have to identify the gap. What do I mean by gap? Okay, so gap is something which makes my sorting even more easier. So how I am going to calculate the gap? So gap is nothing but n divided by 2. So 9 divided by 2 is going to be what? I'll have 4 point something. So I consider the flow value. So it is just going to be my 4. Yes. Ma'am, is my screen visible? Ma'am?
Ma'am?
No, no, I was just asking if my screen was visible, ma'am.
No, no, it became black, ma'am.
Is it visible now?
No, ma'am, it is blank.
Okay, I'll do it again. Is it visible now, ma'am?
Now it is visible, ma'am.
Okay, ma'am. Thank you.
Yeah, okay.
Right. So when my n value is going to be 9, so it is 9 divided by 2, I get 5. Sorry, 4.5. And I take the floor value, so I take 4. So again, so I consider all my fourth digit. So in this value, it is what are my fourth digits? 10, 42, and 80. That is why it is being given with a cream color. So I ensure 10, 42, and my 80 are going to be my value. So I keep comparing it like that. And I keep sorting. So first case I have to take. So 90, 60, 12. So I keep taking my 4 values and then I have to sort my values. Yes. Coming back to our other example. So we've done all this coming back. Yeah. So yes, so shell sort was something which was being invented by Mr. Donald Shell in 1959. Okay, it was the first algorithm to break the quadratic time barrier. Okay, but however, in few years later, they found a sub-quadratic time bound was also being proven. This is what I was telling you in case of insertion sort. We have to go for the number of passes. So n values means we go for n times we have to go for sorting the values. So shell sort generally works by comparing elements that are distant. This distant is nothing but based on the gaps that we calculated. And our formula was number of values divided by 2, the floor of that. So we don't compare the adjacent values. Instead, we compare the distant values. Okay, yes. So shell sort generally, we are going to use a sequence, an incremental sequence for our sorting purpose. It again takes multiple passes. Okay. Another good thing about shell sort is that it improves the overall efficiency of the system by quickly shifting the values to its destination. It is also known as the diminishing increment sort. As I said, radix sort is also known as my bucket sort. The distance between the comparisons decreases, okay, because we are not going to compare the adjacent values. Instead, we are going to compare the distant values. Our analysis of shell sort is that the advantage of shell sort is that it is being very efficient for a medium sized list, not for a larger list. Again, the fastest of all, it's going to be of the order of n square, and it is going to be 5 times faster than bubble sort and twice faster than insertion sort, which has always been its competitor. One more thing is that the reason for this is in case of bubble and insertion sort, we consider the adjacent values. And our main disadvantage is that it is a complex algorithm and it is not like more efficient when compared to our merge, heap, and quick sort. The shell sort is, however, slower than my merge, heap, and quick, but it is, however, very simple. So let me take this example 18, 32, 12, 5, 38, 33, 16, and 2. So my n value here is going to be so my n value here is going to be 8. So 8 divided by 2 is going to be my 4. And okay, floor of 4 is going to be 4 only. So I'm going to take all my fourth digit. So what are my fourth digits? So first, every fourth digit I keep taking my values. So yes, so first I'm going to take my, I hope my screen is visible. So I'm taking my 18. So what are my every fourth digit? 18, and then I compare 1, 2, 3, 4, 18. Then I take my the fourth digit after that. So 5. and then I am going to take my 2. So I am going to compare. So first, what am I going to compare? 18 and I have to compare each and every value. So I compare my 18 and 33. I check. It is in a sorted order, so I don't do anything. So I just leave it as such. Then what am I going to compare? I'm going to compare the other two values. My 32 and the this side next value, 33. So again, this side is going to be a lesser value. Generally, in any sorting, my left side is going to be a smaller value, and my right side is going to be a greater value. So I don't do anything here. The next step. So again, okay. So now what am I going to do? I'm going to increment the floor value. So now again, I have to do it. So now what am I going to check? I'm going to check 12 and 16. Again, both are sorted. Sorted meaning 12 is a lesser value, 16 is going to be a greater value. Lesser value stays to my left and my greater value stays to my right. And then finally, I look at my 5 and 2. So here, I am noticing that my 5 is a greater value compared to 2. So I go with my swapping. So swapping in the sense 2 comes here and 5 go back there. So this is my resultant value where my 2 and 5 get swapped. So I just check, is my values in a sorted manner? No, it is not in a sorted manner. So I have to go for the next one. So first case, when I'm calculating my gap value, how I calculate my gap is n divided by 2. So when I'm doing n divided by 2, so I got it as 8 divided by 2, 4. And then what I am doing, that value, that 4. So 4 divided by 2. So I get 2. So now I compare every second digit. So yes, so I'm going to compare the values. What am I going to compare? Initially, I'm going to compare 8 and my 12, 8, 12, 38, and then my 16, and I'm placing it in the appropriate position. Second level, what am I going to sort? 32, my 2, and then my 33 and 5. And then I rearrange it. So what comes first? 2, 5, 32, and my 33. Okay. So this is the pass is over. So I move on to the next value. So initial gap was calculated like n divided by 2. The next level was that value divided by 2. So what is my latest gap value? My latest gap value is 2. And now I have to again do it as divided by 2. So again, what is my value? So 2 divided by 2 is going to be 1. So again, I'm going to compare for my adjacent values indirectly, arranging everything in my ascending order. So this is all is going to be about my shell sort. Does anybody have any doubt? Does anybody have any doubt? Any doubt?
Ma'am, no, ma'am.
Oh, yes, ma'am. So yes, so I've completed my radic sort and shell sort, ma'am.
Yeah, okay, ma'am. Participants, if you have any doubts, you can ask doubts to Sonia, ma'am. Ma'am, I think they don't have any doubts. Participants, if you have any doubts, kindly you can ask to Sonia, ma'am.
I'm happy that it was clear and they understood.
Yes, ma'am.
Our only
Ma'am,
problem was that, yes, ma'am, please.
I have small note like which sorting could be the best one, ma'am?
Ma'am, again, that depends. So again, here, insertion is going to be easier. So that is why here we are going to mention So radix sort is going to be easy when I'm going to have large number of digits. So large number of digits in the sense when I'm going to have maybe the, for example, 4-digit number or 5-digit number, that will be easier for us. Again, insertion sort and all is going to be useful only when I'm going to have a small number of values. And then coming back shell sort, again, when I was just talking about the analysis of shell sort, finally, however, they say merge, heap, and quick are much better. Merge sort, my heap sort, and my quick sort are much better.
Oh, okay, ma'am. Okay. Thank you, ma'am.
Thank you, ma'am.
So, ma'am, shall we wind up the session here?
Yes, ma'am. Thank you. And a
Thank you
small
so much.
apology, ma'am. Because
Ma'am,
of I was not able to connect through my system because of the thing.
no problem, ma'am.
Thank you, ma'am.
We were able to hear more from you.
Thank you, ma'am. Thanks
Thank
a
you so
lot.
much, ma'am.
Thanks a lot, ma'am.
Yeah, thank you, ma'am. Participants, you can leave for the session and you can join by 3 p.m. for the final session.